Here.
Lift off.
Hi, Nick and Terry. How are you guys doing?
We're fine.
We're good. We're good. It's going to be rant central tonight. I can tell you that for nothing.
Well, that's great. A warm welcome to everyone who's joined us on Space Or Live, the Roundup. We bring you the latest and greatest of space news with Nick and Terry, who are both space experts and astronomers. I'll hand it over to them. I hope you enjoy the next half an hour of space news.
Thanks very much. Excellent. Right. Well, we've just come out of World Space Week, which was fantastic, if not extremely tiring. I know I was giving loads of talks, and I'm pretty sure Terry was dotted all over the country doing all sorts of stuff for World Space Week.
Fortunately, until not too much travel.
It was fantastic though. Yeah. Lots and lots going on. This week it's the International Astronautical Conference, which would normally happen in Washington. This year it's live on the internet. They've already put up 1,300 videos. Wow. So if you've got a year free to watch all that, fantastic. Enjoy. But yeah, we are literally bringing you such hot off the press news now. It's steaming. So our first big item. So normally we talk a lot about the rivals, and we will be talking about them as well. But today is, pardon the pun, a prime day for Bezos. So Jeff Bezos' Blue Origin company. Jeff Bezos, obviously most famous for founding Amazon Prime and being the richest man pretty much in the world. Doing a lot of fantastic work in terms of spacecraft. And Blue Origin, unlike their SpaceX rivals, taking a much more measured kind of slow approach, very similar to how China are developing with their space program actually. So today, literally just a few hours ago, if you're watching this live, Blue Origin's Team Blue managed their 7th flight of this booster. So this is the New Shepard, named after Alan Shepard, the first man to do a suborbital flight from the continental United States, first American in space. And by suborbital, basically it goes up, it jiggles about a little bit in low Earth orbit, doesn't actually go into orbit, and then comes back down again. And that's basically it. So for your $120,000 that you're about to spend on that, if you're so inclined, you're going to get about 6 minutes in space, potentially 6 to 10 minutes in space, and then come down today. I was watching this live today, and it was amazing to see just how quick it all happened. So the booster stage goes up, separates, and is back on the ground in just over 7.5 minutes, which is absolutely remarkable. And watching this thing touch down, it's a very elegant landing, even compared to SpaceX with the unfurling of the legs with the SpaceX, the static legs that come out of the Blue Origin, and the kind of more nozzled nature of the engine that they're using, the jet that they're using, is really, really streamlined. The capsule, Terry and I were talking about this before we came on air, is huge. It looks enormous. And the thing that you may notice from that image is the size of the windows. So what they're really pushing for is tourism flights. And giving everyone a really great window seat. And they've kind of decorated some parts of the inside of the capsule in blue, so they're kind of the grip holds and things to grab onto. What's interesting about this mission, though, is that unlike what SpaceX are doing with their kind of they're launching obviously objects into orbit continuously now and resupply of the ISS, and with the Crew Dragon they managed to get 2 astronauts up and down again. What Blue Origin are doing is a lot of testing, and they're aiming towards the lunar missions. So Blue Origin and the Blue Moon are one of the preferred lander options that NASA are currently investigating for the return to the moon in the mid-2020s, we hope. And what they were looking at today was looking at the flight avionics side and some of the sensors and testing systems that are going to be needed to perform a lunar landing. So this thing's had 100 different scientific payloads already, and a lot of the scientific community and the scientific engineering community really like this mission because it gives them a really safe, very configurable, easily configurable way to test payloads in this low Earth orbit in microgravity just for a few seconds or a few minutes. But they put a payload on the outside of the booster this time, again looking at the landing approach system. So they were looking at LiDAR, and they're going for a very autonomous, and they say the most precise landing ever on the moon. Now, I've got a bit of a bone in contention about this, given that Alan Shepard on Apollo 14 probably performed one of the greatest landings ever and then shot a few golf balls off. But then you only have to look at Apollo 12, the second lunar mission. Apollo 11 obviously overshot the mark quite significantly because there were all sorts of issues with the program alarms, the 1201, 1202 alarms, and the alarm struck had to take control and then avoid a massive boulder field to get Apollo 11 down, Eagle down onto the surface. With Apollo 12, their mission was to basically land as close as possible to a mission that had gone there a few years before, the Surveyor mission, which was designed to test a robotic lander and do some surface kind of analysis and sampling. They got within a few hundred feet of Surveyor. I mean, literally, you can see the Apollo lunar module in the background when they're at the Surveyor, pulling bits off it to bring them back to Earth to check for the exposure, on the lunar surface. So this kind of high precision accuracy, yes, I'm sure it will be, but it's kind of a little bit disingenuous to the Apollo guys to say it's going to be the best ever. But the science community, I mean, some of them are repeat customers on this. They've been at least five flights in some instances out of the 7 that this booster's flown. In terms of the crew capsule, I said that the booster came down in just over 7.5 minutes. The crew capsule was back on the ground in 10.5 minutes. Main chutes deployed. Obviously, it's a land-based landing, so it's going to be interesting. They have retro rockets that fire just before touchdown, and they've got a kind of a way to soften the blow. But hot off the press news on this one. So one of my dear friends is a guy called Chuck Dietrich. Now, Chuck was the retro officer on Apollo, so he worked all of the Apollo missions. He was there literally on Apollo 1 when the tragic fire occurred, all through the unmanned or uncrewed Apollo flights. Apollo 4, Apollo 6, when it nearly shook itself apart, through to 7, through to 17, onto Skylab, ASTP, and the Space Shuttle. He retired just the early part of the Space Shuttle. And he was saying that he was an early advisor on Blue Origin for the Team Blue, and he was watching it from his back garden in West Texas today, watching the launch and re-entry, and he said, oh yeah, they went up to 350,000 feet, which Terry told me just before we went on air was about 66 miles, I believe you said, Terry, which is Yep, it is actually space. So about 350,000 feet. And he said the reason that they do that is to minimize the G forces on the crew. So if you've got a bunch of tourists up there, they're going to be chucking up anyway. I mean, it's obvious. You go in the vomit comet. It's called the vomit comet for a reason. People are going to be throwing up and hurling all over this thing. So that's going to be fun anyway, dodging all that. But when they're coming down, one of the key issues that they're going to have to face is pulling quite significant G forces. So 6 Gs, basically your body weighs 6 times as much in effect. So any higher than that, and people can black out, not much higher than that, certain people can black out. And obviously there's going to be pre-flight medical checks and what have you. But it was really interesting to get that little nugget of information, given that they're doing lunar landing descent tests on this mission from a guy who literally helped put people on the moon at mission control. So I just love that. I thought it was really, really cool. And this is obviously the testing system as well, not only for New Shepard, but the next space rocket is going to be called New Glenn. And that's going to be their orbital rocket as well. And then New Armstrong is going to be their kind of deep space mission rocket. So it's a nice, measured, balanced approach. I don't know if you got any thoughts on these guys, Terry?
Yeah, to me, it's amazing just that rocket literally has been fired 6 times before. If that was NASA or the Russians or the Chinese, it's a one-off rocket to get a new rocket each time. Just think how much they're saving by using that. And I don't know what the maximum number of times they're planning to use an individual one. That's 7 times, and it looks as if it's good to go again. The other thing is that you sort of mentioned briefly, they've been running some experiments on this, again, sort of involvement with the public. For example, they put up 1.2 million tomato seeds with it, get them flown into space, and then they're going to be distributed around school kids throughout America and Canada, and they can then plant them and see how they develop and so on. A few other experiments as well, but yeah, I think as everybody has found now, the best way to get support for any space program is to get public interest and public involvement. So that's what they're doing.
Absolutely. Just as a side note for this, I'll show this on air. This is a satellite kit. So this is an actual satellite. It's a Sprite Sat, very, very small. And this is going to be sold on Amazon Prime in the next couple of months. It's really, really interesting, very low cost. It's about £50 and you get your own satellite to work on, and then it's about 200 quid to get it into orbit. More on that in a later show, but it's really interesting that this whole democratization and commercialization of space is really, really taking off. The only other thing I've got to say on this today, part of the press conference today and part of the kind of build-up, Jim Bridenstine from NASA was on there, and Terry mentioning the cost. You only have to look at the overrun costs on the Space Launch System, the SLS. At the moment, they're estimating it's sitting at around about $17 billion. Now, each launch on this thing is going to cost anywhere between $500 million to $900 million, with SRBs, almost at the cost of a SpaceX mission. So I think the future is definitely painted now for NASA, JAXA, Roscosmos, the Chinese Space Agency, etc. in terms of reusability is the only way to go, because they're not going to be able to compete. So probably talk a lot more about that in future shows, but all power to Jeff. Really good mission. Love it to bits. On to our next story. So this is a lot of fun. The opposition. Ooh, little bit jump there. So SpaceX SN8. So it's now looking like a space rocket and not a grain silo. It still, to me, looks like a Tintin space rocket. The stainless steel approach that they're adopting there. But this is the SN8 test, and this is where they're going to put 3 Raptors on. So the Raptor engines, these gimbling engines, immense amounts of power on the full launch stack is going to be like dozens of these things powering the full Starship into orbit. They're hoping to do pressure tests and cryo tests, leak tests, overpressure tests, obviously. And I love the fact that SpaceX have got what they call their test, fly, fail, fix mantra. It's like they test it, then they fly it, and if it fails, they fix it. And they just keep going and going. And it's really good. Aiming for 2021 as their first suborbital flight, which is astonishingly ambitious. I know you've been following this closely, Terry, as well, the Boca Chica site. Have you got any thoughts on just how quick they're moving?
Yeah, absolutely. I don't know whether you can call it a space race or not. It's not the same as the political rivalry between America and Russia during the 60s and 70s. But there is obviously competition between 2 private companies. Not necessarily just to get more money, but I think it's for the prestige and the public feedback that they'll get. We were first to do this and so on. They're both, I think, still being very, very cautious in terms of safety, particularly when they'll be looking ahead to manned flights, or personed flights, I should say, crewed flights. But yeah, it's amazingly quick. The interesting thing about this particular test, although the fuel will be LOX, liquid methane and so on, they tested it with liquid nitrogen in this case, which I think is even colder, minus 196 degrees centigrade. So that's sort of the ultimate test for cryogenics, basically, because any metal, when it's cooled to that degree, it shrinks basically. And you don't want leaks developing and so on whenever that happens. So I think they have over-tested it by using liquid nitrogen, which is good to see. Better to be safe than sorry on that.
It's what you tended to see if anyone remembers the space shuttle launches or even the Apollo launches. You'd see kind of large blocks of ice falling off the sides of the tanks, and the SRBs, especially obviously sadly with the Challenger disaster, it was one of the key issues with the actual temperature, not only the air temperature, but obviously you've got the temperature of the tanks as well, but the air temperature is what did for the O-rings on that. But yeah, you tend to see these large blocks of ice, and it's going to be an issue that obviously they're going to have to manage as much as any other company with, falling debris and possibly striking into components or anything external on the spacecraft. So it'll be interesting to follow, definitely. If they go for a launch next year with a full stack Starship, that's going to be something to watch. Yeah. It's going to be huge.
Yeah, I mean, the whole thing's going to be taller than the Saturn V, 400 feet, and it'll take 100 tons into low Earth orbit. So it's some machine.
Yeah, it's those engines as well, those Raptor engines. It's one of those things, you look at them in isolation, you think, okay, well, the F1s are bigger, but then you see just how many they're going to put onto it. It's almost like the N1, the Russian equivalent to the Saturn V at the time, which had this multi-clustered engine array. That obviously failed for all sorts of different reasons. You can Google and find out the reasons behind that. There was some catastrophic failures with the M1, blew up on the launch pad. They reckon it was the largest non-nuclear explosion created by human beings in history. And then another one of the flights blew up a few seconds after launch as well. So we're hoping we don't ever see anything like this. But this is the thing with Elon Musk and his team, the Boca Chica team. There's the thing as well that's interesting with Boca Chica is there's no official kind of feeds from there. They do lots of official launch feeds, etc. from the Cape, but all the testing that they're doing in West Texas in the Boca Chica site, it's kind of like third parties that have set up cameras there just to watch it, but the feeds are they're still so popular. So if you haven't seen one yet, when this goes up to potentially 50,000 feet, it's going to be worth watching. absolutely for its test. Definitely.
There's one benefit of the Texas site. I presume that the humidity is a lot lower. So there'd be less ice forming on the cold outer surfaces. I don't know if that's one of the reasons why they chose it, but that certainly would be a good benefit of that site.
Absolutely, absolutely, and it's near to historic mission control, as they say. Anyway, that's a nice one. Moving on to our next story. This is a cracker that Terry found today. I love this. Go, Terry.
Venus was in the news just a couple of weeks ago with the detection of phosphine in the atmosphere, which could be a biomarker, an indication of life. The latest thing now is that they think there may be rocks from Venus on the moon. And why would be interested in that? Why not just go directly to Venus? Well, as we were talking about Venus before, Venus is hell, basically. It's incredibly hot, incredibly dense atmosphere, thick clouds, and the atmosphere is poisonous. It basically rains sulfuric acid. So that was one of the reasons why it was thought there would never be any life on Venus, or not at the moment anyway. Then they came up with the idea that there might be life up in the upper atmosphere. So we want to try and find out a bit about the history of Venus. And for all sorts of reasons, which are far too complex to go into, we think that billions of years ago, Venus might have been quite like the Earth, liquid water on the surface, a much more reasonable atmosphere, not nearly so dense. So there would be the possibility of life. Now, it's not like that now, but what happens if a really big asteroid hits Venus and blows bits of Venus off into space? Where would they end up? Well, some of them could possibly end up on the Earth, in which case it'd be interesting because they'd be contaminated by life on Earth. But if they landed a long time ago, they would have been pretty much destroyed either by weathering or by subduction by tectonic plate movements. But that doesn't happen on the moon. Anything that landed on the moon from Venus would still be there. Now, why is it important to be able to go back so far in Venus's history? The reason is that for the last couple of billion years, probably Venus has been uninhabitable because of the runaway greenhouse effect. But if there ever was life, or even if there wasn't, just studying the geology of Venus as it was a long time ago will tell us a lot about how Venus has evolved over the millennia, millions of years. The thing is that back then, Venus's atmosphere was so much thinner that if a big impact occurred, the pieces of rock would have been able to escape from Venus. If there's a big impact on Venus now, the atmosphere is so thick that anything blasted off probably would not permanently escape from Venus. But if the atmosphere of Venus a couple of billion years ago was as thin as the Earth's, then rocks could have been blasted out into space. And then, of course, they would go off in any particular direction, not directly to either the Earth or the Moon. But the orbital dynamicists have said, yes, a certain amount of them would eventually have reached the Moon. They reckon about 7 rocks in every 10,000 would end up on the Moon, and they'd still be there. So go to the Moon, and we'll be able to get bits of Venus as it was several billion years ago. That's the theory. I don't think it's just quite as simple as that. For a start, those rocks are going to have been in interplanetary space for probably a few million years at the very least before they actually end up on the Moon. During that time, they'll be blasted by solar radiation, by cosmic rays, and so on. When they eventually land on the Moon, they're also going to be blasted by micrometeorites and basically pulverized. They talk about gardening on the Moon. Now, that's not the sort of gardening we talk about. What it means is the continual turnover of the top surface of the Moon by little meteor impacts, which will churn up a little bit of rock, dust, soil, or whatever, and redeposit it because the Moon has no atmosphere at all. So anything that landed on the Moon several billion years ago is probably, unless it's a very big rock, it's not going to be still on the surface. The other thing is that the Moon has a total surface area equivalent to the total surface area of Africa plus mainland Europe put together. That's a heck of a big area. So how do you go about finding a particular rock which might not look any different from anything else lying on the Moon and say, yeah, that's one from Venus? So they may well be there. Whether they'll be able to find them easily or not is another matter.
I'm very skeptical about this. I think it's a fascinating story, and there is one meteorite, because if you don't know, I am a big collector of meteorites.
Oh, I know.
Yeah, this is a meteorite. This is a piece of Vesta, one of the asteroids. So big collection of meteorites. Now, there's one known meteorite, one of the Northwest Africa classified meteorites, that is purportedly got a very similar chemical composition to the surface of Mercury.
Yeah.
So the issue that I think you've got is twofold in this, in that one, yes, Venus's atmosphere back in the day was a lot more tenuous, but you've still got a planet pretty much the size of the Earth. So you've got an escape velocity of round about the same escape velocity as the Earth, which is not, it's not insignificant. So it's going to have to be quite some impact to do that. Then you've got the whole issue of solar dynamics and the dynamics of the solar system, where objects tend to fall inwards. So we get peppered with quite a few meteorites from Mars. We've got loads and loads of instances of lunar and Martian meteorites on the Earth, which we found over the past 20, 30, 40 years, and now been definitely identified as being from those places as origin, because we can cross-reference against the Apollo samples for the lunar ones, cross-reference against Viking, Spirit, Opportunity, etc., for the Mars ones. So, but they're all falling inwards. Whereas with Venus, obviously being closer into the sun, this thing's going to have not only to get the escape velocity to get off Venus's surface, but then sufficient velocity to get out of the solar system, which is no mean feat. However, if this is true, then this could be, again, really a complex issue to prove, because Venus's atmosphere 4 or 5 billion years ago was completely different to how the atmospheric constituency, density, etc. is now. And the same with the Earth. The Earth's atmosphere at that early epoch was completely different, totally toxic to any life. So completely different to how it is now. So if we were to find a rock on the moon that was anomalous, how could you prove it was from Venus and not possibly from the Earth? The other interesting one is that if we were to say, okay, this has definitely come from Venus, if it were to contain primitive microbial fossilized life, could it be the case that life on Earth came from an accelerated development of organic life on Venus, for example, due to its higher density atmosphere, proximity to the sun, possibly accelerated development, as it were, before it went into runaway greenhouse? And therefore, you've got a reverse kind of panspermia coming out of the inner solar system to us. What I think is going to be really interesting looking at this story, and I really do like this story a lot, is the possibility of finding more Earth rocks on the moon. Because one of the things that we don't have, because of the plate tectonics and the geology on the Earth's surface, is really in-depth, detailed history of the earliest stages of the Earth, as it were. We know that, you know, there aren't any surface rocks on the Earth older than about 3.5 billion years. There aren't any life forms. You know, there's the stromatolites off the coast of Australia, that probably the earliest life form that we know of on our planet. So if we can find a rock that's we can prove has been on the moon, either due to its depth or its embedded nature, or, you know, for whatever reason, from XRD analysis, X-ray diffraction analysis, etc., that you can prove came from the Earth, maybe during the late heavy bombardment period of 4 billion years ago, that to me would be amazing, because you only have to look at the Mars rocks and the fact that the atmosphere and water in those basically shows you what the conditions were like on Mars 3, 4, 5 billion years ago, for example, or whenever it was blasted off from the surface, because the kind of the capturing of the atmosphere inside these rocks gets transferred to the Earth. So there's still bits. The reason why we know that these rocks came from Mars is we've got evidence of trapped Martian atmosphere, for example, in some of the meteorites. So if we could prove that with the moon, and when we go back to the moon in the next hopefully 4 or 5 years, to be able to pick up Earth rocks from that epoch, I think would be absolutely incredible, because then you could almost say, well, at 4 billion years ago, the Earth's atmosphere was doing this, and potentially life could have been it, or who knows? But there's so much science from this. So I literally love this story. That was such a cool find, Jerry. I love it.
Yeah, there's two angles on that, actually, because the formation of the moon is another very, very interesting subject. The sort of the Mars-sized impactor with the glancing impact. In theory, some of the rocks on the moon could date back that far. So how do you identify them? One other thing just about Venus, of course, is that any asteroids moving in the orbit of Venus are going to be traveling a lot faster than they do at the orbit of the Earth, because the closer they get to the sun, the faster they're going. And the impact velocity, the energy from the impact velocity goes up as the square of the speed. So any impact on Venus for a given size object is going to produce a much greater explosive effect than the same impact on the Earth. So that's one thing that acts actually in favor of the theory. And as I say, I'm no orbital dynamicist, but they have worked out that about 7 in every 10,000 pieces blasted off Venus could end up on the moon.
Undoubtedly.
Yeah.
I mean, the inner solar system was hammered in the early formation part of the solar system with the late heavy bombardment 4-ish billion years ago. There's also that theory that's gaining a lot of kind of traction that Jupiter's orbit was completely radically different in the early part of the solar system, and that could have had a major impact in terms of dragging these extremely high velocity impactors onto the surface of Venus. And because Venus is very volcanically active, or was volcanically active much more in its past, again, the resurfacing that you'd normally say, okay, where are the evidence of the big craters and the huge impacts? If we can get detailed magnetometry, for example, from orbit on Venus that shows potentially, yes, this could have been a gigantic crater impact or a gigantic impactor, much like Mare Orientale on the moon, which is just this enormous, absolutely huge crater impact. Things like that would be really good kind of evidence to say, well, yeah, this is potentially it, but we do need surface sampling. This is the thing. At the moment, we've only got radar data. We've got the Veneras, obviously have done some landings, the Russian Veneras in the 70s and early 80s. But to get really detailed kind of data on that, you'd need to go down and do some soil surface sampling on the surface of Venus in a number of spots to say, okay, we've now got very detailed spectroscopy on the surface composition rocks, and then possibly tie in. But then the problem you've got with that, Terry, is that the atmosphere on Venus has done exactly what the atmosphere on Earth has done.
Sulfuric acid,
it's just wrought havoc. So who knows?
Rather you than me collecting samples on Venus.
Yeah, it's going to need some spacesuit. We've got to do a story on spacesuit soon, because I've got a real bone about the new NASA spacesuits for the moon.
Oh dear.
Because they look like Buzz Lightyear, but we'll go on to that on another day. Anyway, moving on. Speaking of rants and bugbears, right, here we go. Ranting time. No, being serious, we've talked a lot about mega constellations, as they're known, these large constellations. SpaceX obviously getting FCC licensing for 42,000 satellites. Then you've got OneWeb and Amazon, and obviously whatever China, Russia, and everyone else decides to do. So the impact on optical astronomy is kind of quite well known, and SpaceX have taken some mitigation to kind of reduce the albedo, the reflectivity of the satellites, by putting sun visors on, changing the orbits, etc., painting them darker. That's fine for optical in terms of out of sight, out of mind for the general public. It does nothing for real astronomy. I mean, average amateur backyard telescopes can easily hit magnitude 20. We've talked about this before. The satellites are going to be about magnitude 8 or 9. So every telescope on Earth is going to pick them up. The biggest problem seems to be not in the optical domain, though, for astronomy. It's going to be in the radio domain. So there was a conference held last week with the Royal Astronomical Society were there. They were present, and they were talking about this with a lot of radio astronomers. Now, radio astronomy relies on multiple things. The energy, the total energy, just to put this into context. So radio astronomy kind of around about 80, 90 years of radio astronomy that we've been doing inadvertently or accidentally or on purpose, from the earlier work of Jansky, etc., the work of Penzias and Wilson in the 60s, discovering the cosmic microwave background from radio horn feeds, led to the Nobel Prize. On now to some of the big telescopes. So we've got the Arecibo Telescope we mentioned a few shows ago, which has recently got damaged, one of the largest non-steerable telescopes in the world. Then we've got the FAST telescope in China, which is the largest telescope on the planet at the moment, radio telescope on the planet. This is absolutely enormous, and so enormous that they had to move all the little villages near this telescope in China away from it. The reason for that is radio interference, RFI, radio frequency interference. So your mobile phone, your cell phone, if you're listening from the United States, causes radio frequency interference. Your washing machine causes radio frequency interference. If you turn on the engine in your car, it causes radio frequency interference. Some things are easier to filter out than others. Some things are a real pain. So typically, if you go to like the VLA site in the United States, a very large array run by the National Radio Astronomy Organization, NRAO, they'll tell you, don't have your mobile phone on. We can literally detect your mobile phone and we won't be happy about it, kind of thing. So it's always time. You go to Jodrell Bank in the UK, turn your phone off. It's good manners. Filtering this stuff out is incredibly complex. It requires quite complex algorithms and computers and filtering systems to remove all of this radio frequency noise. And that's just from ground-based objects. So as I said, telescope, one of the big telescopes being planned at the moment is the SKA, the Square Kilometre Array. This is going to be the biggest telescope in the world, effectively, when it comes online. It's going to be generating 10 times the global internet traffic per day from a telescope. I mean, they're having to rebuild the fiber optic connections from South Africa, where part of it is based, the mid and high frequency array, and Australia, where the low frequency array is based. This thing's going to be able to survey the entire southern hemisphere sky 40 times faster than anything that's ever been built before. It's astonishing, generating vast amounts of data. Each of the telescopes having to be cryo-cooled and filtered. So the computing power to actually do this doesn't exist right now to have the whole SKA online. They've got I think it's about 65, 70 telescopes now online and operational in South Africa with the Meerkat system, which is kind of one of the what they call precursors. They've got the low-far array. They've got some of the telescopes in Murchison in Australia for the low frequency as well. And they're already generating data, but when the whole thing comes online, as I said, it's going to be astonishing in terms of radio astronomy, or it would have been had the mega constellations not come along and completely destroyed it. So the problem with some of the frequencies, the square kilometer array goes from a few tens of megahertz up to gigahertz, like 20 plus gigahertz range in terms of radio spectrum. So this is a vast amount of the radio spectrum that it's constantly looking at in different slices in different areas, and it can survey vast amounts of sky, or it can narrow down to very specific regions. Now, given that a radio wavelength is like a bazillion times longer than an optical wavelength, the SKA is going to be able to generate radio images. Have you ever seen a radio telescope image? It looks a bit like a child's coloring thing. It's kind of, it's very kind of blocky and bitty compared to an optical image. The SKA is going to be so huge that its resolution is going to be comparable to something 50 times greater than the Hubble in terms of the spatial resolution of this thing. It's astonishing. Or would have been, had the mega constellations not come along. So these constellations that are promising high-speed internet to the whole planet are using specific frequencies in the 10.7 to 11.7 gigahertz range. This is called, I think it's called band 5 or whatever. This is basically band 5B. So this is a really important band for radio astronomers for detection of things like glycine and amino acids. And they also have a license granted for the 40 to 75 gigahertz band. So the radio astronomers went, oh, we'll go to higher frequencies. No. The FCC have granted licenses. So these constellations for inter-satellite connectivity are going to be using very high frequency bands, because high frequency, they can get increased data rates, etc. So somebody did some calculations on this. So the NRAO put in a massive objection to this. National Radio Astronomy Center in the United States served the SKA. Phil Diamond, who's the head of the SKA, really opposing this quite vehemently. I mean, they recognize that the satellites are important, but it's going to literally destroy radio astronomy. And what they think is that just with the Starlink constellation alone, it's going to wipe out 70% of the data that's going to be available from radio telescopes. Now, as I said, this has been going on for decades. Radio astronomy is like 80, 90 years old now from Jansky. The total amount of power currently detected in that length of time since the 1930s through to now is enough to light a light bulb in your house for a few seconds. That's it. The amount of power involved in radio astronomy is minuscule. And they have to use massive amounts of amplification and filters, and they have to filter out everything that your Auntie Mabel's doing with a washing machine in Perth. If you're down in Sydney, they've got to literally filter out everything already. Putting all of this junk, I mean, okay, it's not junk, it's orbital satellites that have currently got a 2.7 to 5% failure rate, and that's already been documented. So let's not even go into the junk and debris side of things, but this is a real nightmare for radio astronomy. If it goes beyond Starlink and we get OneWeb and China and Russia and everyone else and up to 100,000 satellites, active satellites, dominating the entire radio spectrum, that's certain bands of radio astronomy dead. They're never going to be able to do anything. And this includes detecting, as I said, things like amino acids on exoplanets, being able to do real science, being able to look at the potential for life on external worlds. And it's just, oh, I can't believe how angry I'm getting about this. But if I was on the BBC and I'd have to be impartial, I couldn't be, because there's no impartiality. I love SpaceX for what they're doing with, Falcon 9, Falcon Heavy, Starship, etc. It's amazing. It's absolutely fantastic. What they're doing with this is nothing more than like corporate pollution. And it's not just them, it's everyone else as well. And in terms of decimation of both optical and radio astronomy and our night sky as we know it, Okay, the general public may not see it, but everyone who's got a telescope as a hobby is going to see hundreds of these things. If you've got a wide field survey telescope, like the Large Synoptic Sky Telescope or some of the survey telescopes at Mount Lemmon in the Catalina Sky Survey in Arizona, they've got massive fields of view, like 10-degree fields of view. They're having to already cope with the number of satellites. I mean, it's 3,200 active satellites and inactive satellites in orbit already. You multiply that by a factor of 20, you're never going to get any decent images. It's just going to be satellites. It's going to be like a spider's web. And that's the optical side. The radio side, 10 times worse, because filtering out all this is going to be literally next to impossible. The radio filters, they literally said, we don't know what to do. So I don't know what your thoughts are on this, Terry, but... The angry emoji there is my my feelings.
The good thing about radio astronomy is that it works 24/7. Daylight, nighttime makes absolutely no difference. Cloudy makes absolutely no difference. Brilliant from that point of view. But these satellites are going to be there all the time orbiting. And if a mobile phone can disrupt the signal when it's sort of basically underneath the dish or sideways, just think how bad it's going to be when these things are actually directly up in the field of view of the dishes. It's the worst possible scenario. They're hoping that the United Nations Office for Outer Space Affairs, UNOOSA, may be able to do something on this, but it looks as if the cat's out of the bag. It's almost too late to do it.
It's the FCC. I said the FCC have already, the Federal Communications Commission in America have already granted the license. You're talking about the sensitivity. Let me put the sensitivity of the SKA into context. It could detect an airport radar at 30 light years.
Yeah.
Okay. 30 light years away. It can detect a mobile phone signal on Proxima Centauri, right? Which is a star system nearly 5 light years away from us. 5 years at 186,000 miles per second. We're talking trillions and trillions of miles. Yeah. So if you've got a bunch of satellites at 200, 300, 400 kilometer orbits, it's going to be a mess. So what can we do to stop it? Write to your MP, write to your governor, write to your senator, just say, we've got a problem here. Yes. Yeah. There was some great stuff that was posted about the Washington State and the fires and the fact that the first responders were able to use a beta version of Starlink to get communications. Yes, we need global communications. Don't get me wrong. There's other ways of doing it. There's fiber optic ways of doing it. There's less satellites. You don't need that many satellites, 80 to 100,000 satellites between Starlink and all the others. It's going to be, forget the debris problem. I mean, don't forget the debris problem because that's the biggest problem. But the radio astronomy and the optical astronomy problems, they're equally as pressing for science. And if we want to continue to do science on this planet in astronomy, then good luck.
Yeah, big problem.
Anyway, rant over. Moving on, something a bit happier. If you've not seen the image that we're showing you in the background here, and it's quite a zoomed in close-up version, all I can recommend is go on the internet, type in Anthony Wesley, who's an Australian astronomer, amateur astronomer, Mars images. Right, this guy, along with the likes of Damien Peach and Christopher Goh and various other people, are taking advantage of what is just incredible. So Mars right now is at opposition, which means it's closest point to the Earth. And we say about DRI, it's amazing, isn't it, Terry?
Yep, absolutely. I mean, even the last opposition, the images were not nearly as good, although Mars was actually closer to Earth slightly. But the advances in imaging and software and processing and so on are almost exponential. I know lots of our own members in the IAA, not quite in the same class as Damien Peach, and so on. But they are getting absolutely amazing images, much, much more detail than you can see yourself through the eyepiece, which is disappointing because I just love looking at things as well as seeing photographs of them. It's 39 million miles away at the moment. It won't be this close again until the year 2035. If you have any sort of a telescope at all, you'll probably be out looking at it, but even if it's just a pair of binoculars, you're not going to see any detail on it with binoculars, but bring out the brightness and the amazing, lovely red color. And the interesting thing about Mars at the moment is if you're prepared to get up early, you can see it and the brightest of all the planets at the same time. If you get up around 5 or 6 o'clock in the morning, Mars will be starting to get lower over in the west, and Venus will be rising over in the east. And Venus is even brighter than Mars, so we talked about that earlier. And in between them will be Orion, just sort of more or less halfway in between them, with its retinue of the surrounding bright stars, and Sirius down below to the bottom left of Orion as we look at it. If you take the 3 stars in Orion's belt and follow them down to the bottom left, you get the Sirius. And the interesting thing is just to compare the brightness of those objects. Mars is about roughly halfway in brightness in between Sirius, the brightest star, and Venus, the brightest planet. Now, anybody who has a telescope, I'm sure any of the expert astronomers have already been out looking and imaging Mars. But if you've only got your ordinary sort of little, as the Americans say, a dime store telescope, still go out and have a look. You'll be able to see the polar cap, although the polar cap is actually shrinking at the moment because it's Martian summer. It's the southern polar cap that's tilted towards us at the moment. And the interesting thing about this is that the way the polar caps expanded and contracted with the Martian seasons was what first led people to think that there might possibly be life on Mars, because they were fairly sure that the polar caps on Mars were like those on the Earth. In other words, they were ice. Water ice, could have been carbon dioxide ice, and now we know it's a bit of both. But the way they shrank during the Martian summer indicated that they were melting. And if they were melting ice, they were releasing water. And people thought liquid water on the surface of Mars, bound to be life there. There was even an effect, which is largely imaginary, that there was so-called wave of darkening, which spread from the poles towards the equator as the water was released, as they thought, from the melting caps. We now think most of it actually sublimes and doesn't go directly into liquid water, but this is what they were thinking at the time. And again, as we mentioned earlier, some of the more imaginative ones imagined a whole system of canals on Mars to take the water from the melting polar caps down to the civilizations that they thought were there near the equator. Now, you'll not see anything like that with a telescope. I needn't be talking to the expert Mars imagers because they already know what to do. But quite, if you have a telescope, have a look at it. Even if you haven't got a telescope, just have a look at how beautifully bright and orange color it is. And the orange color is a reddish color is due to oxidation, which means that there's been water and mass on Mars in the past, and you're basically seeing rusty colored rocks.
It's worth having a look as well. I mean, it was interesting looking at it in the past with what's called the Schmidt-Cassegrain telescope. So a lot of the planetary images tend to use these kind of what they call folded design telescopes, where you've got of mirrors, because it increases the focal length and therefore gives you really high magnification, quite a narrow field of view, but really high magnification. So if you are looking at a good planetary telescope, the Schmidt-Cassegrains, the Maxitoff-Cassegrains, if you want to go on Twitter or whatever, just ask for people's recommendation for planetary telescopes. They're the ones that you should be looking at if you want to even get good views. I've imaged Mars and been able to see the polar caps and some of the major surface features with like a little kind of 90mm Maxitoff in the past. If you want to get images like this is a 14-inch Schmidt-Cassegrain, very popular with the planetary images. But what I love about this image is that the volcanoes on Mars, so Olympus Mons is this volcano on Mars that's literally the size of Texas in the United States. And it's got a very kind of distinctive shape. It's amazing that you can see that from the Earth. This is, as Terry said, 39 million miles away, and people are imaging surface features on another planet, imaging volcanoes, extinct volcanoes on another planet. It is remarkable. And what Terry was saying about the kind of the old perceived view of Schiaparelli in the late 1800s and the early 1900s, and Percival Lowell and the building of the Lowell Observatory, which eventually helped find Pluto, all because Lowell was obsessed with Mars and kind of looking for these canals and evidence of life. And obviously you've got H.G. Wells and War of the Worlds and all sorts connected with that. So definitely worth seeing. If you've not had a chance, definitely go out and see it. If you've got access or you want to go on any of the online telescopes and SLUs and companies like that, they do regular like viewing nights where you can look at the planets. The great thing about Mars as well Some of the images have been taking videos, so they've been taking like time-lapse images every, say, 2 or 3 minutes that shows that the planet rotates, which means that it's a globe. So if you ever want to dismiss the flat Earth theorists out there, just show them some of the videos of either Jupiter rotating or Mars rotating, because flat disks don't rotate in that way. So there you go. Enjoy.
You can watch Jupiter rotate in real time if you observe it over a couple of hours and see the pictures moving, you know, from the disk, the limb of the disk towards the center and then towards the other side, and you can see them literally foreshortening, like the Great Red Spot, just as precisely it is a disk, or is a globe. Sorry. Yeah. Okay.
Don't say it's a disk.
Oh, no, take that back.
Finally, then we'll just kind of touch on other things to see, as we always do. A little quick roundup. What's to see? Mars, obviously the big one. Jupiter and Saturn are still very prominent in the sky. As Terry said, Orion. Orion's stunning. If you've not seen Orion through a telescope, it's one of those things to look out for. The Orion Nebula M42, Messier 42, definitely worth having a look at if you've got a good telescope. Good, nice dark sky location, reasonably large telescope. You may even catch a glimpse of the Horsehead Nebula, which is just to the left of the 3 belt stars in the middle. It's like literally tagged onto the far left star in that part of Orion. But you need a really dark sky and a really good telescope to see that. Or if you've got a camera and you can image it, it's one of those things that it's a wow thing to see for the first time. There's other stuff though, isn't there, Terry?
Yeah, we have one of the reasonably good meteor showers coming up with the maximum on October the 22nd. It's the Orionids, because the meteors appear to come from Orion. Now, not from the main part of the constellation as we think of it as the figure of Orion, the mighty hunter. It's actually up in the top left corner, nearer to the feet of Gemini, the next constellation along in the zodiac. But basically, if you can find Betelgeuse, the bright red supergiant star that we talked a lot about earlier, up in the top left corner as you look at it, and a bit further up to the top left of that, that is where the Orion meteors appear to come from. Now, they can appear anywhere in the sky, but if you trace their track backwards, they will intersect in that point there. You may also get a couple of other sporadic meteors which come from elsewhere in the sky, but that's where the Orionids seem to come from. They're parts of Comet Halley, little particles that were emitted from the comet at some of its orbits around the sun. They trail behind it, and every year we pass through that trail of debris left behind by Comet Halley. They're fairly fast, so they streak across the sky pretty quickly. A few other little things to look for, just if it happens to be clear tonight, right through into the early morning, you'll see a lovely waning crescent moon. That's when it's shrinking in phase right beside Venus. So that'll be a nice thing to look out for. And as I said earlier, if you look at about 6 o'clock in the morning, compare Venus in the east to Mars in the west, and Orion and so on in between. If you have a telescope, we already talked about looking at Mars. If you have a reasonable telescope, have a look at Venus as well, and you'll see that it's not a full disk like a full moon. It has a phase because it also is only getting its light from illumination from the sun. And it's around about 75% illuminated at the moment. So if you look at it with a telescope, very, very bright, you might need to use a high magnification to sort of spread the brightness out a bit. You'll see that it's a gibbous phase, like a moon, which is in between first quarter and full moon. So those are some of the things to look out for.
That's fantastic. And I got to show my kids early part of lockdown, actually, a few months ago when Venus was high up in the evening sky, showing them that the Venus was a planet. You could see the phase, and it's fascinating. So if you've got kids, take them out. Definitely make sure that they see this stuff. It's one of those things that, you know, at certain ages, especially the difficult times that we're all living through right now, there's loads of great things to do. And the beauty of astronomy is it's a wonderful free hobby. Just as we close up, I want to say again, a massive thank you to the team who helped put this on with the Space Store. And remember, we mentioned last time all the amazing experiences that they've got, the VR experience. Hopefully, if we're not locked down by the time you hear this, or if you're watching this again on YouTube, give them a visit. They really are a nice bunch of people, great team. They do fantastic outreach in STEM. They really believe in kind of delivering space to everyone. It's not a unique or a kind of a niche hobby. It really is for everyone. And this is what Terry and I love about doing this. It's like trying to communicate what we love about space to all of you. And as I said, huge thanks to the team at Space Store for everything they do on that front.
Yep, absolutely.
Awesome. Thank you so much, Nick and Terry, for another incredible roundup. As Nick said, do visit Space Store if you're in and around Didcot. We're open 11 to 3 every single day. Thanks for watching. If you're watching this on catch up. Now, before you go, I have a little favor to ask. We at Space Store have been working really, really hard over the past few months, trying to bring space to everyone, everywhere, every day. And the roundup has been a big part of this. So thank you to Nick and Terry for putting up this wonderful show every other Tuesday at 7:30. Now there is a small survey we'd like you to do. It's going to be in the link in the description below. So please spend 2 minutes of your time filling that out, and it's just going to help us shape Space Store Live going forward, so we can better our service and bring space to everyone. Thanks a lot for your time. Thanks for watching. Please do subscribe if you haven't already. Thank you, Nick and Terry, for another incredible roundup. We'll see you guys again in 2 weeks' time at the same place. Until then, take care. Goodbye, and we'll see you again soon.
Good night from me. Keep looking up.
Cheers.
Cheers. Bye.
Bye.
Guys, see you later.